Yeah, can you see the screen, the paint?
Yes, sir.
Okay. So in the last class, I had said that we have two objectives. One was efficiency and the other was equity. So normally we would expect that we require two instruments because we have two objectives. Now the fundamental theorems, we have two fundamental theorems of welfare economics, and these fundamental theorems tries to look at how these objectives, efficiency and equity, are attained in this general equilibrium framework. So you can see that it looks at the static properties of the Pareto equilibrium. Now before starting the or stating the fundamental theorem, can you tell me whether the model that we have studied, whether it is a case of conflict or whether it is a case of cooperation? I mean, for instance, take the production domain and take the consumption domain. So this is the production domain. We have the Edgeworth-Bowley box for production and we have the isoquants. This is isoquant of E. On the other hand, this is the consumption domain and we have the utility levels of E. We also have these are the isoquants of the second firm. Okay, now tell me whether this is a case of cooperation or conflict. If you look at the two producers, X and Y, can we describe the situation? How do we describe this situation? Conflict or cooperation? Are they cooperating or are they each trying to maximize their own welfare irrespective of what happens to the other person? And keep in mind the conditions that we derived earlier.
Sir, cooperation because they are involving exchange.
No, there's exchange between producers and consumers, you can say. But even in this exchange, are the producers thinking about their own profit or are they thinking about the utility of consumers?
their own profit.
Their own profit. In case of production, what is the producer of X interested in? What is he trying to do? If you have to state his objective function, what is he maximizing? The producer is maximizing this function. Okay, this is X. In case of Y, Y equal to f g of L Ly ky. Sorry, I've written both of them. So this is wrong. This is Lx, so this will be also kx. Okay. In case of y, it is right, and these two functions. What are the consumers doing? Can you hear me?
So maximizing utility, subject to budget constraint.
Yeah, so they are maximizing utility. I've not put subscripts.
Sir, but we have not defined M here, sir.
No, we have not put in M over here because we had not maximized this. What we had done was looked at the point of view not of the individuals but society. Okay, that is why we in yesterday's class I did not bring in C, I did not bring in M. But if you think about it, what are the conditions that we had derived? We had derived MRS equal to, I think it was mu1 by mu2. Now if you interpret this as prices, what do we have? When do we get this condition? If you solve this?
Yes.
What was MRTS? I don't remember. No, we didn't prove MRTS actually. No, but we did prove it.
Sir, MRTS X
was-
is equal to MRTS.
No, but what was the expression? Again, if you look at it, we get some ratio which can be interpreted as WR. So that means producers, if you look at the individual producer, he's trying to maximize this function. Okay. So the objective function that we maximized, the optimization exercise that we looked at yesterday, was from the point of view of society. But if you look at the individual agents, all of them are trying to maximize, they have their own maximization problems. Now if you look at the functions, basically, see, the firm is trying to maximize something, the consumer is trying to maximize something, but basically, are they concerned about themselves or are they concerned about society or the other consumer?
So themselves only.
So they are concerned about only their own utility in case of a consumer. In case of a producer, only their own profit. Now if you look over here, you will see that the producer X will try to move higher over here. B will try to come higher over here. So it is essentially a zero-sum game. So in this situation, exchange is occurring in the context of this zero-sum game. Okay. So in this situation, it is basically what we can see to be a cutthroat world. That is, I'm looking at only myself. You are looking at only yourself. Udita is looking at only her own welfare. Okay, so everyone is out only to maximize his or her interests. I don't care about what happens to you. You don't care what happens to me. In this situation, is it possible to maximize social welfare without coordination? What is your intuition? If someone coordinates and tells you that, okay, see, if you try to maximize too much, don't think too much about yourself, because then it's going to be conflict. You accept this, you make a compromise, and that person will also make a compromise. So someone is coordinating you. Right. This is one possible way of coming to an equilibrium. Or we can have an outright, what is called a command and control economy. Command and control means that there's a dictator or central planner who decides what the equilibrium configuration will be, and he just tells you that, okay, look, Oyan, you have to do this. So you don't have any freedom. I will tell you what to do, you will simply carry out my instructions. And this goes for everyone in the class. This is what is called a command and control. Okay. Alternately, I can give you instructions and give you incentives to follow my instructions. So all these is basically some sort of coordination. Without this coordination, can you all self-interested agents maximize the collective welfare? What do you think? Owen was saying something.
Sir, Adam Smith.
Okay. Upanita, what do you think?
Yes, sir. Like, let the market be on its own without any interference.
Okay. So the first fundamental theorem states a competitive economy will always be Pareto optimal. And remember that we had defined efficiency in terms of Pareto optimality. Okay. Now, how do we prove this? The proof is fairly straightforward. If you look at the consumers, this is A. A utility maximizing consumer is going to be at a point, choose a consumption basket which satisfies these this condition. So A is going to satisfy this condition, and for B it's the same condition. Now, when are the price ratios different? When is PA not equal to PB?
So if X is more valuable to consumer A than consumer B.
Sir, no competition.
This is the market price. Yeah, what were you saying?
I was telling that if it is not a perfectly competitive economy.
If it is a monopoly?
Yes, sir, price discrimination.
Yeah, if you have price discrimination, not just monopoly. Now if you have price discrimination, then right, but if you're talking about a competitive economy, perfectly competitive market, can you have price discrimination? In a competitive economy, you don't have
No, sir.
price discrimination. Okay. So, PE is always equal to PB for both X and Y. Okay. So that means these two ratios will be identical. PAX is equal to PBX, PAY is equal to PBY. So we are going to have this condition, which is the first Pareto optimal condition. So if you have utility maximizing individuals, then in a competitive market there is no price discrimination. So individuals are going to be in equilibrium when MRSA equal to MRSB is equal to the common prices. Okay. So automatically this condition is satisfied. Okay. Can you prove the second Pareto optimality condition? This will be satisfied in a competitive economy.
Sir, input prices is also a price. So can we say that?
Yeah, just a minute. Let me finish. Yeah, so if you have a maximizing firm, profit maximizing firm, MRTS X is equal to, sorry, this will be X, this is X, right? Again, if you don't have price discrimination in the input market, you are going to have WA is equal to WB and RA is equal to RB. Sorry, these should be X and Y.
Sir, I had a question here, sir.
Yeah, can I just finish this notation, please?
Sir,
Yeah.
sir, how will the coordinates, sir, Lx plus Ly is equal to L bar means the input constraint.
Yeah, I
If
don't
both
know.
are different forms.
No, I don't understand what you're saying.
Sir, I was telling that.
Yeah, I
Lx
have
plus-
this. Yeah.
Yes, sir.
Mm-hmm.
How will the coordinate action satisfy this? Means conflict is there. Both will try to maximize.
Okay, you mean to say that if I use more of X, you're using less of Y.
Yes, sir.
This goes up, this comes down. Yeah, what I'm saying is that it's a situation of conflict. So one way is that I sit and I talk with both of you, X and Y, and you come to a compromise. Over here what is happening is that given the Edgeworth-Bowley box, see, if these two are equal, what I'm having is, in the absence of price discrimination, it will simply become right. So MRT is X equal to MRT is Y equal to W by R. Now what does this imply? The two isochrones must be tangential to each other. Okay, so that means if I choose this point isochron, you will be at this point. If I choose this isochron, you will be over here. Okay, so in this way we are going to use up the entire labor force. Now you will argue that I want to move like this, and the X producer will want to move like this. So how do I resolve it? Well, that is where exchange comes in. So over here I'm just showing that this locus, the first contract curve, that will be at the tangency. Okay. Now what was the third condition? CMRS is equal to marginal rate of transformation. Okay. Equal to MRT. Okay. Now we know that MRS is equal to the common marginal rate of substitution is equal to Px by Py. Now what is MRT? It is the ratio of the marginal products okay. Actually, I'm not sure about this, GL by FL or FL by GL. I'll just have to work it out. Okay, now what is important is that if you look at MP, marginal product of labor, or well, not marginal product, if you look at marginal cost of, let us say, X, what is the marginal cost? Just think of, let us suppose that capital is constant, you can change only labor. So what is the marginal cost of increasing production? I've lost you. Connection gone. Okay. Okay. So when did the connection break?
So you were drawing the Edgeworth Bowley box.
Oh God.
So right in the beginning of the explanation actually.
Exactly. Okay, I'll come to the box a little bit later. See, in the production domain, we have okay. So suppose that there is no price discrimination in the input market. Okay, the input market is competitive. This is what we are seeing. So the input market is competitive. There is no price discrimination. Which implies that Wx is equal to Wy and Rx is equal to Ry. Okay, so in that case, we can write MRTS X equal to MRTS Y equal to W by R. Okay. If each component, both the numerator and denominator is the same, the ratio will always obviously be equal. So what does this imply? It implies isocons will be tangential. Okay, so if I have an isocont like this, you will choose this isocont. Okay, you will not choose this one, nor will you choose this one. You are going to choose only this one. Is that right? Do you understand this? So the market is telling you, if I take a decision, the market tells you how you should respond. Okay. Now obviously what I think Owen will ask is that in that case I can the obvious strategy of Y will be to choose an isocont like this so that X has to be over here. Okay. So how I choose between what I basically am saying is that X will try to move like this, Y will try to move like this. How is this coordination attained? That is coming later on. Exchange. Okay, right now what I'm trying to show is that given some person's decision, automatically the other person decision is foreordained by the market. So the market tells the other producer what to do. Okay. Now we come to the third condition, which is the common marginal rate of substitution is equal to the marginal rate of transformation. Okay. Now the common marginal rate of substitution is equal to Px by Py. This is what we have derived earlier. Now let us look into the marginal rate of transformation. Okay. Now let us look at the marginal cost of production in X industry. Okay. What is marginal cost? It is dC by dQ. So let us assume that the allocation of capital between X and Y cannot be changed. So that means if you want to increase the production of X, the only way to do so is by increasing the use of labor. Okay, so only labor can be increased. This is just simplifying, because you can also do the opposite. It doesn't matter. So if you are increasing labor, what is the additional cost? What is DC equal to? You have increased output. How can you increase output? By increasing labor. What is the cost of this decision? It is W into DL. Okay. If you want to do this in terms of capital, it will become R dk dq. You can also do it in terms of capital. Okay. Right?
So what it be Wx?
I've already told you that Wx and Wy are the same. So I don't need to write subscripts.
Oh yes, sir.
So this is W, and what is this? The marginal product of L. So MCX is equal to this. Now remember that firms are profit maximizing agents. In a competitive economy, in a competitive market, what is the condition for maximizing profit?
Sir, P equal to MC.
Okay. Here we are talking about MCX, so it is equal to PX. In Y it will be MCY equal to PY, right? Okay. So if I take the ratio MCX by MPY, this is PX by PY, but I have shown this to be MP this will be Y. Okay. MPXL, which is the definition of MRT. So MRT is equal to this price. Now this is the price which consumers are paying. This is the price which are paid by the producers. Sorry, they don't pay it, they receive it. When is there a gap between these two prices? When is PX not equal, this PX not equal to this PX? Let me put in slash over here.
So tax.
Exactly. So if I have a profit tax, this will be, or lump sum tax, will the price be different?
The same.
If I have a profit tax, so this has to be a unit tax or ad valorem tax, something like that. Okay, non-distortionary, or rather it has to be a distortionary tax which changes the price. So in the absence of taxes, we are going to have so basically what we get is CMRS is equal to MRT, this is equal to prices. Okay, so that means consumers, or rather firms, simply have to choose their maximize output subject to an output constraint. They have to maximize profits. Consumers will simply have to maximize utility subject to a budget constraint. Each of them is totally unconcerned with the other people. But the result of this is the price mechanism coordinates the individual self-seeking maximization in such a way that the resultant general equilibrium will be Pareto optimal and efficient. Okay, so this is what Adam Smith called the invisible hand. So basically what Adam Smith had suggested but not proved was that the price system coordinates actions of self-seeking agents to maximize to ensure an efficient equilibrium. Okay, is the first fundamental theorem clear? Is it clear?
Yes, sir.
Yes, sir.
Yes.
Okay. Now, what we had simply said was that the economy is going to be on the, if it's a competitive market, the economy will be at a point on the grand utility possibility frontier. Okay, so if markets are competitive, I'm going to be at a point like this. But it can be a point like A, it can be a point like B, it can be a point like C, it can be a point like D. Now, if you look at A and D, these are cases which are heavily tilted in favor of one of the agents. If you end up in A, then B is going to enjoy a lot of utility while the welfare level of A is very low. In case of D, it is the opposite. So when we are talking about efficiency, we have not brought into consideration equity. It doesn't mean that the equilibrium will be equitable. Okay. The second fundamental theorem states that don't worry, first focus on baking the cake. Again, over here you don't have to worry, the market will ensure, the price mechanism will ensure that you end up with the largest possible cake. Now the question comes that, okay, you have the largest possible cake, how to divide this between A and B equitably. And look, equity doesn't mean equality, it can come, as I've said repeatedly, it can relate to some, it relates to a notion of fairness. What this notion is, I'm not going into it right now. Okay. So the second fundamental theorem relates to equity. The problem is that if I try proving it is quite complicated. You require Brouwer's fixed point theorem, which is quite advanced mathematics. It's part of your PG course. So what I'm going to do is simply state the second fundamental theorem. What the theorem says is that each point on the GUPF corresponds to an initial distribution of resources. What does it mean? What are the resources with the consumers? Sneha, can you tell me what are the resources available with consumers? Rajashree, if you think that interrupting the class to ensure your attendance is important, then please you should log in before, in time. Don't interrupt the classes with these requests.
Sorry, sir.
No, I'm talking to not Rajashree Datta, Rajashree Khan.
Okay, sir.
Yes, sir. Sorry, sir. Sorry.
Okay, Sneha, are you there? Sneha? Okay. Anushka? Are you there?
Yes, sir.
What are the resources available to the households?
So, consumption goods,
No, they are buying this from the market. Right?
income,
How do they get their income?
sir, by giving factor services to firms.
Thank you. So that means they start off with a certain amount of endowment of labor and capital. Each household has a certain amount of labor, a certain amount of capital. This is the endowment. When I'm saying initial distribution of resources, I'm talking about this distribution. Okay. Now, if you have a very unequal distribution, okay, see, we are talking about only two people. So let us say, drop these terms. So we have got only L1, K1, L2, K2. Suppose this first person has a lot of labor and a lot of capital, and the second person has a very low amount of labor and capital. What is going to be the income? Which income will be higher, or will it be same?
So the income of A.
The A's income will be higher.
Is going to be quite higher.
Yes, sir.
So that means when they go to the market, A will have more market power. Okay, and we are going to end up at a position like D. On the other hand, if we assume that L2 is greater, L2 and K2 is much higher, then we are going to end up at a point like this. Okay, so we can have different distributions. See, if you have L bar and K bar, you can distribute L bar and K bar between the households in different ways. Corresponding to each such distribution, you have a point on the GUPF. So that means if you change this distribution, sorry, it should be L1. So corresponding to this distribution, you have a point on the GUPF. And if you change this distribution, you will move from one point to another point. Okay. So now the solution to the equity problem becomes very easy. If you can identify a point which is more or less equitable, let us say B, what I can do is, corresponding to B, point B, I have an endowment. Okay. My actual endowment is something different. Let us say this is the actual endowment. Okay. What I can do is, we can introduce a non-distortionary tax, a tax which doesn't change the price levels. That is, it is a lump sum tax, head tax, a poll tax. If we impose a non-distortionary tax and change the distribution of resources, so I move from this distribution to this distribution, and then I step aside. So now if I start from this distribution, where will I end up? I'm going to end up over here, which I want to do. This point B corresponds to my notion of equity. So if I can change the distribution from this one to this one through a lump sum tax, I'm going to end up at an equitable point. Okay. Remember that once I change the distribution of resources through the lump sum tax. After that, I step aside. The first fundamental theorem starts operating and I move to point B. Also keep in mind that if I impose, let us say, a distortionary tax, a tax which changes the price level, in that case, MRS by equal to MRT, that condition is going to be violated. Or maybe some other condition is going to be violated. There will be at least one condition, one of the Pareto optimality conditions, which is going to be violated. So even though I end up in B, I will not be able to reach the GUPF. So we should not impose a distortionary unit tax, ad valorem tax, taxes like these. It should be a lump sum head tax, which keeps the price ratio unchanged. By price ratio, I mean all types of prices: input prices, output prices, prices paid by the consumers, prices received by the producers. All the prices should, none of these prices should be affected. Okay, is it clear, everyone?
Yes, sir.
Okay. So now the question is, there are several questions over here. See, what I have said so far is that you have competitive markets in which you end up on the GUPF, and if you impose the Bergson welfare function, you are going to arrive at a point, at a constrained bliss point. Okay. So it is possible for a competitive economy to be efficient, equitable, and we see that we can also maximize social welfare. Okay. Now there are several questions over here. Is it possible to derive a social welfare function? See, when I say that you have a utility function, you have an indifference curve, what I am saying is that there are several commodity bundles. Okay. You have some commodity bundles, let us say X1, X2, X3, X4, and you can rank them. Okay, so this is a possible ranking. Sorry, it should have been P. X1 is preferred to B. Let us say X2 and X3 are indifferent. X3 is preferred to X4. So I can rank these commodity bundles. So I have alternatives and I can rank them. Now, this ranking is being done by an individual. Okay. Now, when I am talking about a social welfare function, this also implies the ranking of alternatives. Upanita, when is your deadline?
Sir, it's okay, so you can continue.
No, when is your deadline? I can continue
Sir.
next week also.
So I'll leave by 5.
But you need time to get ready. Okay. So one is you have to rank alternatives, right? See, if it's an individual, if I ask you that Upanita, can I continue the class till 5:30, or I end at 4:30? What will be your ranking?
So 4:30.
Okay. But when I'm asking a group, okay, so I have a group of members A, B, and C. All of them have a ranking. Okay, so I'm asking them to rank. He may say that okay, X, P, Y. He will say that X, I, Y. He may give a different ranking. Okay, so every people has a ranking, but it is consistent. Can I aggregate the individual preferences to form a collective or group preference? This is what is called the possibility question, on which Arrow, Sen and others have worked.
So could you repeat that question once?
What I'm seeing is that I'll come back to it later when I'm treating this. When I'm talking about an individual, I can ask you to rank the alternatives consistently. You may be mad, in which case you rank them in inconsistently. I'm ruling out mad people. A rational individual will rank alternatives in a consistent manner, right?
Yes, sir.
A society comprises of several individuals, each of whom ranks the alternatives consistently. Okay? So you have a preference ordering, Prithviraj has a preference ordering, Deepika has a preference ordering, and so on. If I have the information on your preference ordering, can I club them together and generate a ranking or preference ordering for the entire class? Okay, this is the what we call the possibility question. Okay, in other words, what I'm trying to say is that all of you are rational individual. You can rank alternatives. Based on this information, can I generate a social welfare function? This W1, W2 that I've drawn, can I generate such functions? The second question is that okay, I have shown that the first fundamental theorem of welfare economics, the first theorem states that if you have competitive markets, this will lead to an efficient equilibrium or Pareto optimal equilibrium. Okay. Actually, this raises two questions. And that is why I will not put 2 over here. I don't want to put 2A and 2B. The first question is there any alternative way and in particular, can the planning system, so we have a centralized planning board, socialism. Can a socialist government where there is no markets, you only have the planning system, is it possible to attain Pareto optimality in this type of economic system? This is the Lang-Lerner theorem. The third question, also related to the fundamental theorem, is that okay, this theorem is based on certain assumptions: competitive markets, perfect information. These assumptions may appear very innocuous, but they are very strong. Okay, so the fundamental theorem of welfare economics is based on very strong assumptions. What happens if these assumptions are not satisfied? In that case, we have the case of market failures. Traditional market failures like externalities, public goods, or information related market failures, moral hazard, adverse selection, and the principal agent problem. And it leads to the second best theorem. What happens in that case? What should we do? So, we have arrived at the crossroads, you can see. There's another question which I forgot to say, that okay, the answer to this possibility question. See, suppose it's possible to derive a social welfare function. Then I know that okay, this is the point which I want to arrive at. But suppose the answer is no. The Bergson welfare function cannot be derived. So what I have is, I end up with a partial ordering. Okay, and remember another thing, that when I'm talking about a welfare function, I'm bringing back interpersonal utility comparisons. Suppose I don't want to do that. It's possible to derive a welfare function. I don't want to do that. So, what I'm trying to say is, without bringing in interpersonal utility comparisons, I end up with a set of Pareto optimality points given by the GUPF. And I don't know how to choose between them. So, interpersonal utility comparisons, if I rule them out, I have a partial ordering. I have the GUPF which are all possible alternatives. How do I choose the best point from here? And the answer to this question is given by the works of Higgs, Calder, and Skitowski, and it is based on the compensation criteria. Okay. So my next question is that the answer to question number 3 is, we are going to go to 3 at the last. But which one do you want to go next? 1, 2 or 4?
Sir,
It's
1.
your choice. 1. Okay. Not today, by the way.
Okay, sir.
Sure 1? Not 4? 4 is easier.
So then 4, please.
But you'll have to come back to 1.
It's okay. Let's start with the easy